Let's look at final exam question number 83, found on page 678 of Teach Yourself Electricity and Electronics, 5th edition. We're talking about a medium Earth orbit satellite. Now, medium Earth orbit satellites are interesting because in most cases their orbits are highly elliptical. So they're a lot closer to the Earth at some points in time than they are at other points in time. The point of closest approach to the Earth is called perigee, and the point at which the satellite is most distant from the Earth is called apogee. Now, as a satellite orbits around the Earth in this elliptical fashion, as you might remember from your astronomy courses, the farther away an orbiting object is from something of constant mass like the Earth, the more slowly it travels. So as a satellite like this orbits, it zips by the Earth rapidly at perigee and tends to hang out there pretty slowly, tends to crawl along pretty slowly at apogee. For that reason, a communications satellite like this is easiest to access from Earth-based stations, not at the closest point, which you might at first think, but at the farthest point, apogee. That means that the correct answer to this question is C, as in Charlie, apogee. Now, the reason is that in a situation like this, you're going to need a directional antenna in order to access the satellite. And if you happen to have that directional antenna pointed at the satellite, you're going to want to not have to turn it really fast. You're going to want to be able to leave it in place for a little while, and if the satellite is at apogee, you'll be able to carry on a communication for a little while before you have to turn the antenna again. But if you do it near perigee, you're going to have trouble tracking that thing as it goes across the sky. In fact, some of these satellites at perigee are less than 100 miles up, and they'll go from one end of the sky to the other, one horizon to the other, within only a couple, 3 minutes. Whereas out here, it may hang out there in the sky for the better part of an hour before you have to turn the antenna. It all depends, of course, on what the actual perigee and apogee are for the satellite. Another advantage of apogee is it gives you a greater range between stations that can communicate. As you can see, if you draw lines out to the satellite at apogee, two stations almost on opposite sides of the Earth in this drawing would be able to communicate with each other. Their antennas pointed at the horizon. They could both access the satellite and both see it. And of course, in order for any two stations on the surface of the Earth to communicate through a satellite, they need to both see it. Whereas at perigee, in this particular drawing, you can see that the communications range would be a lot less. So that's another advantage of apogee as being the best time to use a medium Earth orbit satellite. Ham radio operators have traditionally used this type of satellite. And it's really interesting if you ever get a chance to see a ham radio station that's equipped to communicate through these satellites. The last full weekend in June, they have an event called Field Day. Ham radio operators, Field Day. Their radio clubs go out into the wilderness or sometimes just into a city park, and they will set up stations that oftentimes have the capability to communicate through ham radio satellites. So if you ever get a chance to see that in action, I would really recommend that you do that. But again, the correct answer, C as in Charlie.